So hello friends, welcome back to my channel Medicine 101. Today we'll continue the bipolar limb leads. Okay, so let me tell you guys, I have already uploaded a video based on the bipolar limb leads where I have already talked about how the limb leads are getting formed. Okay, now basically today I'll focus over here that the Einthoven's triangle and the Einthoven's law. Okay, so before that let's go once again the limb leads. I'm just taking the individual over here. Okay, now see is the limbs and let's let me draw this part over here. As you know, this is the lower limb over here. Okay, now I already talked about these things that how can we make the circuits. For example, it's the galvanometer over here is the galvanometer over here through these 2 points. Now one point that will get connected with the positive electrodes over here. Okay, another will get to what over here. Let's draw a little bit up for this one. Anyway, see. Now see, another will get what? That will get connected with the negative electrode in this in the right wrist. Is the left wrist over here. And we will also did talk about that here we are taking on negative, here we are taking on positive over here. For example, here we are taking, the galvanometer. Let's draw in this way. There is also 2 points for the 2 electrodes. One is getting connected with the negative one, it is getting connected with the positive one. Now in the same way for the negative over here we are just taking the positive over here. Okay, and definitely I have to take in terms of the electrodes over here. 2 points, it is getting connected with the negative, it is getting connected with the positive. Okay, now just like this we have already what the circuit. It's the circuit of the leads. For understanding purpose, I'm just taking the heart. Okay. Now let's repeat once again whatever we learned last time. Whenever the major ventricular depolarizations we will see over here, as a result we will see that what the electrical vector that will go where the electrical vector will get that will go downward and leftward, downward and leftward. Now for understanding purpose, I am saying over here whatever the electric potentials will get, whatever the potential difference will get in the wrist, the same amount we can get on the shoulder here in this region. In the same way, whatever we'll get over here, we'll get in the same things over here. Okay. For making triangles, I'm just taking this part over here. Now I'm just taking is the negative part. Okay. For example, let me show where. Let me show in this part. And another negative, another positive over here. For understanding purpose. Okay. And whatever the things we'll get over here, you already know. I've already said you that we'll get the axis electric, whatever the axis, lead axis, we'll get what the first lead over here. And for example, we'll get another what the negative for this one. I'm just taking over here, and we'll get the positive and positive over here. Now in the same way, we'll get the lead number 2 whenever we'll connect these two. So let's make it more clear for you. Okay, the axis, so it will get the lead number 2 over here, and we'll get also one negative over here and one more positive, it is a positive over here, and we'll get another one this one. So let's make the positive a little bit closer. Now see, now this is things we are having the 3 sets, lead number 1, lead number 2, and lead number, this is the lead number 3. Okay, lead number 3. Now try to understand from here that I have already said before that when electric potentials, or we can say the electrical activity that will be found within the heart, the same amount of the electrical activity that will be spread in all about the body parts, because the body contains the fluid. There are various kinds of electrolytes that will help to conduct the electrical activity. Okay. So the same things will go over here and also in the lower limbs. Now I have taken these two parts over here. Okay. Now see, for understanding purpose, let me see one thing over here, that the potentials. See, this is going what, left and downward. So definitely the potential here will be more positive, and this is the left side. So you can see in terms of the what, in terms of the lead number 1 in this side, it will be more positive. And what about the right, what about the upward and the right side, because the vector is going left and down. So in the same way, it's positive side. So in the same way, you can say that in these positions, what, the value for the potential, that will be negative, or it will be less with comparison to the body's potential. Okay, that will be the average potential with respect to the potential of our body. Now see, what type of the potential you can get. For example, we will get over here minus 0.2 millivolt. Here we will get how much? Minus 0.2 millivolt. Okay, and here in this persons we will get, in the left side, so we will get positive little bit, so we will get 0.3 millivolt, and we will get the maximum wire within this region, so we will get around plus 1 millivolt, plus 1 millivolt over here. Okay. Now see, basically we use to to measure the potential difference in between the electrodes. Now if we see in terms of the lead number 1, just try to understand from here. Okay, let's talk about in terms of the lead number 1. Now see, whenever you are talking in terms of the lead number 1, now see, whatever the potential difference, it is, you are getting plus 0.3, you are getting minus 0.2. So for these things, if I just draw a graph over here, okay. Now see, for example, is the 0 previous line. Now here we are getting minus 0.1 millivolt. Here we are getting minus 0.2 millivolt. Here we are just taking minus 0.3 millivolt, and above we are getting plus 0.1 millivolt. We are getting plus 0.2 millivolt. We are getting plus 0.3, plus 0.4, plus 0.5. Okay, and plus 0.6, plus 0.7. Definitely it will be always plus, because above 0 you have to consider in terms of plus. And I'm just erasing this part over here, and whatever this one will get plus 0.8, plus 0.9, plus 0.1. So that means we will get plus 1. Let's erase this part also, guys. And for example, we get over how much? Plus 1.1, and we are getting plus 1.2 millivolt over here. Okay, plus 1.2 millivolt. Now try to understand from here. If we just do the electric potential in terms of the lead number 1, in lead number 1 I have already explained you that whenever we will get the in terms of the potential difference in terms of the two electrodes. Okay. Now see, here we will get how much? Here we are getting minus 0.2 millivolt. Here we are getting plus 0.2 millivolt, plus 0.3 millivolt. Now if I consider here, I am getting the baseline over here is 0.3 millivolt, and we are getting the next thing plus 0.3 millivolt. Now we are getting the plus 0.3 millivolt. Now we will get, this is for the lead number 1, so this will be for the lead number 1. Lead number 1 will get over here. So ultimately we are getting how much? 0.5. So if you just do the difference 0.2, if you just count from here to here, we will get 0.5 millivolt. We will get 0.5 millivolt. So whenever we are getting in terms of the lead number 1, so 0.5 millivolts, we will get what? The positive deflections. So positive deflection, if you want to represent in this way, definitely we will get how much? 0.5 millivolt in terms of the lead number 1. Now in terms of the lead number 2, if I say over here, let's talk about first lead number 3. Okay, now lead number 3, if we just say what is the potential over 0. Plus 0.3 and plus a, how much is over here? Plus 1. So plus 1 and plus 0.3. Now see, where is 0.3 is over here. 0.3 is over here. Let's make the electrodes in this way, and it will be easier to identify them. Okay, now see. Now we are getting how much over here? We are getting plus 0.3. Now plus 0.3 is over here, and we have to go up to how much? Plus 1. So where is plus 1? Definitely the plus 1 is over here. So if I make a line just like this, so how much the potential difference will be over here? 1, 2, 3, 4, 5, 6, 7. So we'll get the potential difference for the lead number 3. We'll get the potential difference for lead number 3 is 0.7 millivolt. We'll get plus 0.7 millivolt. So as a result, we will see the deflections over here, that will be also positive. And how much positive? Plus 0.7 millivolt. Now what about, the say lead number 2, that means lead number 2 over here. So how much you are getting? 1 and 0.2. Now see, if I just say over here, let me show you this color. Now for lead number 2, let me show. So 0.2 you are getting over here. Okay, minus 0.2, and maximum is how much? 1. So 1 is over here, 1 is in this way. So 1 we are getting over here. So we'll get how much the electric potential will get, difference will get. The electric potential difference will get how much? That will be how much? From here to here it will be plus 1.2 millivolt. Plus 1.2 millivolt. So we'll get how much? Plus 1.2 millivolt in terms of the lead number 2. Lead number 2 will get plus 1.2 millivolt. Okay. Now if we just represent them in terms of the graph, in terms of the ECG. So for these things, let's draw some more things. For these things I have to erase some part. So where should I erase? Okay, let's draw from here first things first. Now see, if I want to represent the lead number 1, okay, lead number 1 in terms of the ECG. So ECG, in terms of ECG, we know that in terms of ECG, I'm just considering the 5 rows over here. 2, 3, 4, 5. The 5 a little bit larger, so just make it like this. And in the same way, I'm just taking in this way 1, 2, 3, 4, 5. Now we know that the small square box over here, in terms of the ECG, will get how much? In this way, 0.04 second will get, right? In this way. And what about in the vertically? Vertically will get, vertically in terms of the voltage will get how much? Plus 0.1 millivolt. Plus 0.1 millivolt. Now in terms of the ECG lead number 1, whatever the potential difference we got over here, in terms of the lead number 1, we got the potential difference 0.5 millivolt. Now if you count from here, so we'll get 1, 2, 3, 4, 5, just like this. So the potential difference, if I just go over here, it will be in this way. Okay, so for the lead number 1, we will get plus 0.5 millivolt. Okay. Now, for example, if I just say for lead number 3, let's make the same thing over here. For lead number 3, whatever the thing we can get. Okay, now let's make it 1, 2, 3, 4, and 5. Let's erase this part. Okay, so 1, 2, 3, 4. 1, 2, 3, 4, 5. Okay, let's continue. I'm just taking in this way 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now for example, just like this. Now if we take in terms of the lead number 2 over here, whatever the thing we will get in this way. Now see in this, the potential difference in terms of the lead number 3, sorry, it's in terms of the lead number 3 I am just considering right now. In terms of the lead number 3, if you want to represent in terms of ECG over here, so what can you get? Now see, so we know that in this way you will get how much? 0.04 second, and in the upward, in the vertical you will get how much? Vertically you will get plus 0.1 millivolt. Okay, now if you want to represent the lead number 3 over here, what's plus 0.7? Now see, 1, 2, 3, 4, 5, 6, 7. That means we can get in terms of ECG just like this. Okay, now what about the lead number 2? Now I will represent the lead number 2 over here. Okay, for this thing, let me use some part. I'm just taking in this way. I'm just taking, for example, for simplicity, I'm just drawing. Okay, now see, lead number 2. Okay, sorry guys, it's not working. Okay, now 1, we'll get 2, we'll get 3, we'll get 4, and we'll get 5. Now let's continue in this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, for example, in this way. Now in the same way, we'll get over how much we'll get to have to consider in this way, that this direction will get almost 0.04 second, and in this way in the vertical will get almost plus 0.1 millivolt. Plus 0.1 millivolt. Okay. Now whatever the thing will get over here, see, in this way we will get the electric potential difference in terms of the lead number 2. We got how much? Plus 1.2 millivolt. Now if the for vertically, if we get for each 0.1, so we will get how much? 1 2 3 4 5 6 7 8 9 10 11 12. So we will get in this way. Okay, so it will be the physical representation in terms of the lead number 2. It will be the lead number 2. Now what the scientist Einthoven said that whatever the electric potential we will get in this way, that will be always, there is a rule, or we can say the formula, that is always that if we do the additions for lead number 1 and lead number 3, then we will get lead number 2. So that's the rule or formula given by the Einthoven. Now if we just do the comparisons over here, whatever the potential we got in terms of, just try to understand from this here, that if we represent for the lead number 1 we got 0.5 millivolt, and for lead number 3 we got how much? For lead number 3 we got 0.7, and we got for lead number 2, that will give how much? 1.2 millivolt, and 1.2 millivolt we got only in terms of the lead number 2. Just like this, if we just represent in this way, then we will get what? The Einthoven's law, that will be proved. Okay. Now for simplicity, I am just saying in terms of the ECG. For example, I got, it is the for lead number, lead number 1 in terms of the ECG, and for example, it's in terms of lead number 3, reading in this way only, and that will be equals to the, definitely it will be greater, so it will be lead number 2. So in this way we can represent the Einthoven's law. Okay, in the next part we will talk about the pathological aspects. Whenever we will see, if we see any kind of the changes over here, because basically if we just draw the line from here, perpendicular line, most of the portions of the major depolarizations vectors, okay, perpendicular depolarizations over here will get in terms of the lead number 2. As a result, we will see the potential difference, that will be much more greater in terms of the lead number 2. But if you compare in terms of the lead number 1, see, very little part will get in this way, and in terms of the lead number 3, see, we will get in this way only little portions, that will be parallel in major perpendicular depolarizations vector, but in terms of the lead number 2 will get maximum part. Okay, so that was all about the different kinds of the aspects in terms of the voltage difference or difference. Okay, in the subsequent part we will talk about the pathological aspects, where we will describe if we see there is any kind of the changes in this perpendicular depolarizations vector. For example, it is going in these directions for pathological purpose, or in this directions, yet we will see the Einthoven's law, that will be also proved. Okay, so from this law, what can we say over here? From the Einthoven's law, if we know that any two values, that means if we know any two values out of the 3, then I can find out what? I can find out the potential difference for the other one, for the rest one. Okay, in the same way, the another the advantage for the Einthoven's law, that is, for example, if we just if we add, or if we just attach the different kinds of the electric bipolar limb leads over here wrongly or incorrectly, then this thing will be not equal. That means we will not get this formula 1 equals to 3 equals to 2. That will not come. That will tell us that whatever the matchings we did, that is not correct. That means in terms of the bipolar limb leads, we have to say it again correctly. So that's all for today. Okay, see you in the next video, where we will talk about the pathological aspects. See you in the next video. And if you think that video is helpful for you, please do like my channel, and see you soon in the next video.